Hi everyone, and welcome to Design Week 2024. I'm your host, Ulysses Iñiguez, and this is day one. Design Week is a 3-day virtual event consisting of a live stream portion and on-demand talk tracks. Day one is all about managed security. Day two is on makers and rapid prototyping, and day three is for enhancing your designs using AI and ML. But before we get started, I'm going to pass it on to Clifford, who will explain to you guys how you can participate in today's event.
Thank you very much, sir. Like Ulysses said, my name is Clifford, and I will be your guys' host for the Q&A section. We are live streaming on 3 different platforms. We have YouTube, Facebook, and LinkedIn. I'll be monitoring the chats in all 3. It's not just me. We also have a panel of subject matter experts who are also in the chat with me, making sure that your guys' questions get answered. If, for whatever reason, your question doesn't show up in the chat and you still want something answered, you can email me at livestream@microchip.com, and I will make sure that Xavier gets back to you. One last thing I'd like to point out is if you guys were to go to microchip.com/Design Week, it'll take you to this landing page that we made. It gives you more information about our event, but if you were to click this button right here, it takes you to our On24 page where you can actually see the details for the different classes that Ulysses was talking about. So once this live stream portion is done, we have 3 different sections, 3 different webinars for you guys to go into, one of which I think Xavier did himself.
That's correct.
So without further ado, I'm going to throw it back over to Ulysses.
All right, thank you. So we have brought in Xavier as our expert, and we're going to pick his brain. How are you?
Good, thank you, Ulysses. And thanks for having me back again.
Yeah, no problem. He has been with us in the past few years on the show, and managed security has always been a very important problem. What has changed in the past year?
So in the world of security, in the world of embedded security rather, there's a couple of good things that we like in the security world as structure, right? For the years I've been here, the problems that I was reporting is lack of knowledge, right? That was a huge thing, and lack of structure. So the structure that comes in the shape of standards and sometimes regulations, more often regulations to say. It doesn't just stop there. What has happened too is those standards efforts have been occurring through the key market segments. So in automotive, you have ISO, I'm spacing out now, 21434, I think. You have in industrial, you have 62443. You have in IoT, you have the EN 303645. So there's a lot of, we love numbers in terms of standards. In medical, the FDA came up with embedded security recommendation, not regulation, but recommendation. It's very well written. I was pretty surprised when I read it. What am I missing? Automotive, industrial, IoT, consumer, a couple of places. Medical, I'm missing one, I feel. We'll keep it to those 4 for now. When those now that we have those standards, you look at the map of the world, the European have been a leading force in creating that IoT standard. So I'm going to keep it to IoT for a minute there. Many other countries, including the US, Korea, Japan, India, Australia, that's what's on the top of my mind right now, have been following that bandwagon. So they take what's inside that standards, the key notions, the foundations of the standards, and they're implementing or recommending or sometimes legislating, putting legislation in place to make sure you have those principles in place. So that's the structure that I'm talking about. So again, we have standards. I did say regulation. So Europe has been really, it still is the heart of the security lobby, where they're taking the standards and looking at them and say, okay, I'm going to use those principles and start to put legislations in place. That's a big deal. In the US, the Cyber Act is telling us they want to put a security label on IoT consumer product to show that there's a certain level of security reliability, if you want to call it that way, in place in product that you and I will buy, and we're confident that, you know, a foundational work in security has been implemented in a product to protect us, the end users, right? Something new that we started to see popping up among those standards across all the segments, notion of managed security. It's something that disturbed a lot of the experts because you need to manage. There are things that are going to change, that are going to have to be updated, and that's potential risk. So you need to be able to put infrastructure that's going to be dynamic, reactive, that's going to protect your your infrastructure at scale. That means like all across the globe, and that's not easy to do. But that's something you see in the EV charging standards. They're going to tell you rotate the identities. They call that certificates. How do you do this? And that's important because if you pay for the charge of your vehicle, you have a financial transaction that's there. That needs to be unique to you because that's your charge in your car. You don't want me to use your financial transaction to charge my car and spoof it. So there are things like that are showing up in the standard. So that was new in the past, I'd say 2 years about. The last year, there's more and more activity out of customers that we see that are actually implementing against those standards.
All right, so you mentioned these standards, these regulations. What if someone doesn't implement security? I'm thinking, like, what could go wrong?
Yeah, so, when I have that question, my audience would think, okay, he's going to go into the technique side of things, and I'm not. Actually, the scariest thing, and we've seen it happen in the IT industry, right? That's we, the embedded experts, really are learning from the IT industry a lot, and we're scaling their concept down to super small embedded system, right? This is always our philosophy. So what has happened in the IT industry lately, I think it was this year, actually, 2023, rather, if I'm not mistaken, you start to see CISO take, chief of IT, chief of security, different title, different companies, going to jail for it because they didn't take seriously or they didn't disclose correctly a security vulnerability. When that vulnerability has, visible, noticeable impact to us, the end user, or to their companies, and essentially it always end up to us, the end users, there are legal consequences, and that's jail time. So I was talking to a few experts of that that are involved with that scene, and that sets a precedent, a legal precedent for very likely, very, very likely more cases to come up in front of us with all those IoT things, right? So that's one thing. Then you have the notion of attack at scale. So you're taking a whole grid down. We've seen that in 2016. I can't remember the other dates, but that's the reward of the hacker is how much financial value can I get of it, and how much size can I scale my attack into. So if you can tackle a whole grid, the reward is gigantic because you can start access hundreds of thousands, if not millions of devices remotely. So that sort of scale remotely, it's magic. That's the end goal. So we've seen that happen. Look at the news, there's countless examples. So when you see those little IoT attack, hey, I attack this Bluetooth thing, think about how many Bluetooth things that you can actually attack that are out there in the market that are exactly the same product, right? So that's another risk. And how do you deal with that? How do you correct that? It's a massive headache, right? Because it can mean, is it a software fix? Is it a hardware fix? Or back to the manufacturing, redesign, another cycle? That's the nightmare of all of us on the embedded side and our customers. Mm-hmm. And the last point, so I talked about the legal aspects, the impact of scaled attacks. And something that impacts more the brand is the notion of counterfeiting, really. I'm going a little bit beyond IoT, but the brands have been impacted. We continue, I've said that for the past couple of years that I come to the show, where our customers come to us, hey, I'm losing revenue. I'm going to shut my door down because I've lost that much revenue because of counterfeiting. Because at the embedded side, a lot of the IP resides in the firmware. That's where all the engineering, a lot of the engineering goes, but you can copy the firmware, right? If you can copy it, you can multiply it and counterfeit it. So that's how bad it can get.
Yeah, so products being tampered with, letting users down, revenue lost. How does Microchip prevent all this?
So we start with education, really. Again, I've said that through the years, education is the first thing. And when we educate the customers, we talk about threat models. Have you done your threat model? And everybody asks, okay, what's a threat model? The way we'd explain it is you have to be honest with your own engineering and destroy what you just invented. That you're going to start to find vulnerability and all that. That honesty rarely happens because we as engineers invested a ton of time in criticizing our own product. It's not genuine, really. Mm-hmm. So that's where you invite third-party companies. So we have a couple of companies we recommend. Kulowski IoT is one of them. That they come in and will do an assessment of your threat model, tell you this is your threat model. Once you have that in place, you've identified security use cases. How do I do my secure boot? Do I need a secure boot? Most generally, yes. Do I need to authenticate my embedded solution to the cloud? How do I do that correctly, that I'm also in line with the standards and regulations that are coming up, right? And how do you update my firmware? And how does it meet the standards and regulation again? And that's the pattern. So you go from your threat model to the use case, how it meets the regulation. And that's the first layer of discussion we get. So like I mentioned, we ought to bring third-party security company in this evaluation. We do that for our own chips in the security group. We bring in third-party test company that would pen test our devices and give us level of evaluations.
Yeah, it seems pretty straightforward, but what are some common barriers of entry?
So barrier of entry, I've already given the notions of use cases, secure boots, a firmware update and stuff like that. It's what does it mean? So there's notion of knowledge. The notions are complex when you take them down device by device. And once you understood the use case per se, how do you implement it? So from learning to understanding to implementing, there are months and months and months that generally happen at our customers. So the notions are pretty complex too. So to address that, you need tools that serve you education material, that serves you configuration tools, and that serves you, code example, all in one box. Essentially, that's how you probably want to think about filling that gap.
Yeah, from education to tools to products, how does Microchip alleviate those common
So at
problems?
at the portfolio level, at Microchip, what we drive ourselves to deliver is providing a lot of choices to the customer. And I can hear our engineering community and too many choices. But if you think about how fragmented the market is, and again, beyond IoT, you talk about automotive and medical and consumer IoT and industrial, retail, you name it. You got connectivity all over the place. We got counterfeits all over the place, right? So you need diversity in the offering of embedded security solution and that's what we offer. So we can start, with our probably most advanced devices like the PolarFire chip, FPGAs. Recently, a couple of months ago, we released the SAM A7 microprocessors that has trust execution environments with some type of secure key storage. You have I think it was yesterday or 2 days ago, we released a new line of 32-bit microcontroller. I think it's a Cortex M33 with integrated HSMs. We continue to grow a portfolio of secure elements, which I'm going to dive into in the rest of the presentations. We released back in November last year the Trust Anchor, the TA101. That's a more advanced secure element for automotive, industrial markets mostly. So you see that breadth of portfolio is what Microchip is committed to offer to all those segments, that everybody can find their happiness depending on what they're dealing with.
Yeah, so we have this breadth portfolio of products. Do we have any tools to help us along our path?
Yeah, so a couple of tools. We've got the classic MPLAB, MPLAB X to handle the microcontrollers, microprocessors. I think Libero is the tool for the FPGA. I'll start to focus now on the secure elements side of the portfolio, the crypto authentication mostly. We have something called the Trust Platform Design Suite. Actually, I'm wrong. It's not just for the secure element. It's for any Microchip silicon that leverage the secure key provisioning service that Microchip has to offer. So it's the mechanism that Microchip has from our factory to load cryptographic credentials, symmetric key, asymmetric key, certificates, all that stuff. So from our factory into the silicon, we're able to provision, to load those keys. We call that the secure provisioning keys. To get into that service, you have the Trust Platform Design Suite there that we're showing in the screen. There's a couple of platforms we've been launching throughout the year: Trust and Go, Trust Flex, Trust Custom, and the new one released that this month of April. That's the Trust Manager. So that platform comes with a tool called the Trust Platform Design Suite, and I'll go through it at the end of the presentation.
So now that we know how to use our security products, can you show us a visual representation of how managed security works?
Yeah, absolutely. So if you want to focus on the 3D printer here, there you go. So that's just an example. We're taking that demo to trade shows. And essentially the story here, you have, imagine this is a room with a critical piece of equipment that could be dangerous, and that's operated by an operator. So right there, immediately what you have the notion of safety and security that are coupled immediately. IEC 62443 that I mentioned earlier on is that trying to achieve just that, is to marry the notion of safety with security, to protect the operator by creating an immediate reaction on the machine that's connected to a network. So essentially, the philosophy there is you have an asset that has a certain level of value, and that asset is somewhere in space, in time, and it could have multiple owners for that. So you see there are a couple of things that change. There's the time factor, the space factor, and the ownership factors. That's where managed security comes in, dynamic security comes in. So that's just one example. Think about a factory where you have that environment. There are other things. If you think about telemetry, a high-value asset, or maybe an asset that has high-value service around it. You know, an operator that would, let's say a maintenance person that would leave a job site, forget something, he get beaconed by something connected, got to go back. He doesn't waste the time to travel the entire town, go back. That's value. That's money lost for the service company, right? What if it's another operator? No, that's the notion of change of ownership, different ownership, right? Identity that needs to change. What else I can tell you about it? There's also the notion of, so you got telemetry, building access management. So that takes back, I'm going back to this demo here, where you talk about short-term, long-term rental type of models. You have the notions of getting into a corporate building like Microchip here. There are multiple people accessing a certain zone that they have the right of access into. That's managed security will help you to solve all those cases.
Yep, this is a great illustration. Could you just give us some more bullet points on what the benefits are for managed security?
Yeah, absolutely. So, you know, a couple of bullet points. You're preventing instead of correcting. Mm-hmm. And if you think about all the standards that are coming up, again, regulation, I've said that a lot, but that's what's happening. The fear is, so here, let's take the example of the European regulation. The big bullet points that everybody is completely afraid of. In the text, it's written that within the first 5 years of the device lifetime, product companies will have to commit to patch any vulnerability that comes in. There is no way you can predict what tomorrow's vulnerability will be. Does it have an impact on your hardware, on your software, on your cloud platform, all of it together? How fast you're going to react to it? How fast you're going to disclose it? That has a tremendous impact. So if you don't have that, a certain level of agility, so that dynamic managed security approach, it's going to be costly. It's going to be costly for you to react. On the other side of the benefits, you know, there's something more interesting that improves the user experience. So by the user experience, you know, one of the holy grail in IoT is creating subscription-based model. So there you go. It's something dynamic, right? You're going to have to provide something new at a certain frequency to the end user that he enjoys the experience of the product. That's generally a custom piece of firmware that's specific to that end user. And how do we deliver that? You need to deliver that into an infrastructure that's capable to identify exactly who that user is, what does he own, and maybe that ownership can change across time, that you can, in a custom fashion, update those systems, manage those systems, remove those systems from the market and put them back in. So those are other types of benefits. You also have notions. We've had customers that looked at our product and think about they're thinking about pay as you go, buy now, pay later type of models, because again, you dynamically manage the ownership. You can dynamically enable certain level of usage by a certain owner. That's managed security and what it can enable you.
Right. All this information has been great to learn, but where can someone go to get started and learn more?
Yeah, so if you want to switch to my screen, I'm going to tell you where to get started there. I don't know if I can switch to my laptop. There you go. So you go to microchip.com/trust manager. So that's the platform I've been talking about. So if you can, the first thing to do there is to create your Keystream account. Keystream is the Kudelski IoT software service that will manage anything authentication related your embedded system is going to be subject with, really. This is what it really comes down to in a few words. So inside that Keystream account, I'm going to create a space where I'm going to actually occupy space, my space in Kudelski HSM, and I will own that space. So there you go. I'm going to actually do a quick demo there where I'm going to create my accounts. If I click on create, I've already loaded the page just for the sake of time. You're going to register your accounts, create a new account, put in your login, password, create the whole thing. It creates this, this Keystream space. Once I have that in place, don't have to do it again. I can directly connect to it, which I've done. So when I log in directly after creating my account, what's happening here is that's my entry page into my Keystream space. The first thing I'm going to do there is create a fleet of devices. So I imagine I'm creating a fleet of 3D printer, right? You have one, I have one, Cliff has one, and they're all the same model. So see, I've got, I'm going to call that 3D printer. They don't like the space here. I'm going to skip the other field for the sake of the demo, and we'll cross a finger that the demo works, actually. So what I'm doing here, again, I'm creating a fleet profile. My fleet is a fleet of 3D printer. The next screen is where a tremendous value is, but it happens really quickly. So I'm going to go really slowly about it to explain that. What's happening there, I mentioned that we are starting to occupy the space. We're going to start renting space from Kudelski HSM that I'm going to own as the customer. So I don't have to go and figure out who are the providers, how to work with them, how do I customize my root certificate authority, because that's what I'm going to do right now. Essentially here, I have the common name of my root CA, so I'm going to call that XAP for the sake of the example. The organization name, I'm going to type in the Microchip ticker here. Let me type it twice because I probably used it in other demos. I'm going to actually type it three times. How long my certificate authority is valid? So I'm going to say 10 years for the sake of it. And here I'm also creating the device level certificate. I'm going to say it's also valid for 10 years. So I've got my root certificate authority, my device level certificate my device certificate level authority. The private keys of the two certificates are protected in the Kudelski HSM that I own. And I can't tell the service, hey, if my IT department wants me to rotate the certificate every 2 years, I just tick that up. I put 2 years, so what's that? That's 730 days, if I'm not mistaken. I'm going to note that I don't want to turn that on right now, so delete everything. And the moment I click commit, which I'm going to do now, let's see if it works. It did work successfully. What I've done, again, I created root CA with the private key protected in my HSM in the Kudelski HSM environment. I created device certificates with their private key that are stored inside the Kudelski environment. And now if you go into the trust platform, you're going to have to load those device certificates. When that happens in the field. So for the sake of teaching, I talked about we're providing a lot of teaching material. Open my Trust Platform Design Suite, go into the Trust Manager, I preloaded my use case here. And inside my use case, we're explaining all the concepts. We're explaining what slots of the C608 we're going to be calling for. We're going to have the kit. I'm going to show, can we switch the camera that shows the kit here for a minute? There you go. So here's my kit. I'm not going to touch it because they're trying to calibrate the zoom there. So you buy this Trust Manager development kit that has the C608 Trust Manager right there. You get that from Microchip Direct or any distribution store participating to the promotion. You have also this Wi-Fi development kit that you get from microe.com. That's the Wing 1500, so you're going to snap them together right that way. Tuck, tuck. Careful of the orientation. You have a little cut here that matches the little line. So that's how that's the kit you want to get. Can we switch back to my screen here on the laptop? So when I'm on the laptop, I'm offered with this use case. I've left the successful. I didn't want to get into, giving too much luck to the demo to fail. I've run it before, so got all my tickers are green. Sure, all my steps were good. So what's happening there, essentially, you're telling the TPDS to talk to the Keystream SAS and push data into AWS IoT. That's what we're setting up here. So this whole first part of the setup is setting just that up for you. So there's a bunch of credentials you're gonna have to load from Keystream, from AWS to reconcile the account. TPDS takes care of all of that, again, for the sake of teaching. That's our teaching moment right there. The way you connect the embedded system so the way you load those device certificates into the Keystream software as service, you're going to open the, do you have loaded? Perfect. If you click MPLab, I think it's already loaded here. You have the C code example in MPLab that will essentially program you program the microcontroller with, and that will have all the code example to connect the embedded system to Keystream. As soon as the system connects the first time it attempts, Keystream is going to recognize the 608 that's on the board, and it's going to download, it's going to in-field provision, that's the right term to use, in-field provision those device certificates, so that in-field provisioning doesn't happen in the factory anymore, it happens in the field. So there's less error to have the wrong credentials on the wrong device there. And the customer is in complete control of when they want to do that. So that's how you get started.
All right, thank you so much. That wraps up my portion. Clifford, do you have any questions?
Yeah, so before we get to any sort of audience questions, I sort of wrote some things down while you guys were going through your presentation. This morning you handed me a sticker that's on the back of my laptop, and I was wondering if you would go through and sort of explain the differences of all the different logos of the Trust and Go, Trust Flex, Trust Manager, those sorts of things.
Absolutely, absolutely. Yeah. So the big topic of today was managed security. I also call that dynamic security, dynamic management of security. That is the essence of Trust Manager. So Trust and Go, Trust Flex are static solution to a certain extent. So by static, I mean Trust and Go is a solution where Microchip will be the root authority, the utmost authority. We create certificate level, device level certificates, and we load that into the Trust and Go. Once it's locked, we ship it. There is nothing to be done on that Trust and Go silicon. But when it's time to manage the device, you can't do it because the cert chain is static, right? It's a brick. Flex could be looked at the same way, but the difference with Flex is the customer can bring their own custom certificate chain there. So their own customized certificate chain is static also in the Trust Flex. It's time to react. You probably need to change the silicon, not always ideal there, especially what's coming up in terms of standard and regulations. With Trust Flex, you can do more than just cloud connections. You have other use cases to address just local authentication, whether it's symmetric, asymmetric. There are many schemes that are in place, and all those use cases are inside that TPDS. Where manager come in, if we spend a few minutes in that demo, we are offering to the customer that level above the silicon, that software as service level, where customers have a self-service root certificate authority at the tip of their finger. They don't have to go chase and negotiate in the street. It's there. We worked a lot with Kularski IoT to make that frictionless. So you own your custom root CA. And those two words, owning and custom, are really the key words there. That's not something you can do with Trust Flex. No Trust and Go. Trust and Go is not custom and it's static. Flex, it's custom and it's static. Manager is dynamic, it's customized on the fly, and you own it completely. So that's at the very high level. I did say the word static many times. Again, I think we understand manager is dynamic, so you can update, change, revoke, manage the expiration date just in the snap of a few clicks. We went through the whole demonstration there. Trust Flex and Trust and Go are, again, static. When they are there, they never change. And they're still very good solutions, don't get me wrong. Because the question we get now is, when are those regulations going to kick in? The standards are there already. I can tell you they're written, they're pretty well done. There's always some ambiguity here and there, but Go and Flex do address really well what's today in the market, maybe a little bit of tomorrow. We're looking at a 3 years horizon, but we as a semiconductor provider have to be future-proof ready. So that's why we came up with this managed security solution. So those are, hopefully, this hopefully clarify
absolutely.
the differences between the Trust Manager, the Go and the Flex.
I think so. Thank you very much for the breakdown. It sounds like Trust Manager is kind of like a combination, a culmination of all the different features that we were offering before.
Absolutely is, yeah. It absolutely is, yeah.
I think it's pretty cool. If somebody were so inclined to use it or purchase it, how do they go about doing so?
So there are two ways. If we no need to go on my screen, but if we go back to this microchip.com/trust manager page, at the very bottom you'll see two flows. We talk about the auto claiming flow and the claim by manifest flow. So on the claim by manifest flow, it's the experience we've been delivered with Trust and Go and Trust Flex. With the semiconductor, once it's provisioned with the credentials that are corresponding to the Go or the Flex platform, we deliver a manifest file. So it's essentially a JSON file in technical term. That JSON file includes the public keys and the certificates, the public information like serial numbers that are attached to the the semiconductor we provisioned at Microchip. So provision in that case is done by Microchip. And that manifest is delivered in the e-commerce account of the purchaser, okay? That manifest needs to be uploaded in the cloud platform of the customer. So for Go and Flex, generally what happens, nobody really knows what the customer platform will look like. So there are scripts that get involved. With Trust Manager, we have a simple browsing mechanism that you go fetch the manifest wherever you stored it. That's the claim manifest. You load that manifest in Keystream, and the device are essentially claimed as soon as they connect to the platform. Very, very smooth. The second flow is even smoother than that. The manifest notion still exists, but Microchip has pushed the integration to a level where as soon as we manufacture the chips, we provide the manifest to the Keystream a software as a service that's owned by Kudelski. The way you get access to that, you have to create your account first, and then you place your order. If you flip the sequence, that flow is not going to be enabled anymore. You will have to, if you order the device first and then create your accounts, you will have to claim by manifest. I'm going to repeat myself for the sake of reinforcing the message. The auto claim, you open your cloud account first, then you place your order, and your device will populate in your accounts. If you order the device first and then open your cloud accounts, then you're going to have to claim the device using the manifest and upload the manifest in Keystream. Those are the two different flows to order devices.
Cool. Thank you very much. So you mentioned that this is functionally software as a service. Let's say somebody wanted to add, or they didn't need a particular feature. Can we go about customizing that?
Yeah, absolutely, absolutely. That's actually, we have a few customers that they are, the situation that I've started to see happening is, hey, I've used your parts, your Trust and Go, Trust Flex parts, and I need to be compatible with what I've done in the past. So now, but they're interested by the management side of the service. So that you basically essentially take the Trust Manager configuration and push it into a Trust Custom. We look at the minimum amount of space needed to manage your credentials, right, in the configuration of the device, and the remaining space is for the customization of that. We're able, of course, to drop the Trust Manager platform into other silicon if memory is a problem, like the Tier 101 would be a very good candidate. So that gets into more custom type of approach, but it's possible.
I got you. And then my final question, there's a lot of good information, it's phenomenal, but there's a lot of steps to follow. Do we have any sort of written tutorials that can sort of guide people along their journey?
Yeah, absolutely. So I think, I don't know if you're showing or I'm showing, we can go back again. Are you showing?
Yeah, I think I got them pulled up already. I think I cooked the books with that question.
So what we've done, and we're going to continue to do that a lot. If we go back to the bottom of that page there, Is that me?
It's you, but now it's me.
Okay.
All right.
So we go back to the bottom of this page, absolute bottom. So you have a blog and a video tutorial. The video tutorial takes you from, hey, create my Kularski account to connect the board, and the board is connected and everything in between. That includes all the steps that I was showing through TPDS. I talked through the whole thing. We'll be updating that tutorial very soon, but this one is very accurate to get you started. I'm going to drill, create a bunch more videos to drill into the concept of root certificate authority. That's a question we've been having. The notion of in-field provisioning. So you're going to see more video from me and my team being pushed in that page. So follow that page, follow us on YouTube, and you're going to see all those videos in our channels.
Cool. Thank you very much. So that was my last question. We have some people in the audience that may be typing up a question, but if we miss you guys, just email us at livestream@microchip.com. And like I said earlier, I'll make sure that we have your guys' questions answered. Before we close everything out, I would like to remind you guys that the event doesn't just end when this live stream does. If you go to microchip.com/Design Week, it'll take you to this page, like I showed in the beginning, and here are our 3 classes for after today. So yeah, check them out. They're not just available today, they'll be available whenever you guys are so interested. And I think that's all I have for you guys.
All right, well, thank you, Clifford. Thank you, Xavier. If you haven't subscribed to our YouTube channel, please subscribe to our YouTube channel. And just a reminder that tomorrow we'll go over makers and rapid prototyping. And day 3 is enhance your designs using artificial intelligence and machine learning. Thank you guys so much for tuning in for today's show, and we'll see you next time.